Okay, so we're going to solve this problem that was a part of your 201 exam review. And question 1 here asks to replace all the forces in the system with the equivalent resultant force and couple, and we want the couple about point O and about point P. So the first thing we're going to do, we're going to start by putting each force into their respective components. So here we have two components of the force, 420 times 4 over 5 and 420 times 3 over 5. And this force here, we have 315 cosine 30, and we have 315 sine 30. So the first thing we can do to find the resultant force let's start by summing all the forces in the x direction. I'm going to say that the right direction is positive, which gives me 420 times the 4 over 5 component, and that's positive because it's going to the right, minus 315 sine 30, minus because it's going to the left. The sum of those two is going to be 178.5 pounds. We're going to do the same thing in the y direction. We're going to say up is positive, and we have 420 times 3 over 5. This is positive because it's going up. We have minus 315 cosine 30. Excuse me. And that's equal to negative 20.8 pounds. Negative means it's going down. So I always like to draw on my new x and y axes to show where those resultants are, or at least which direction they're in. But they're going to be the same regardless of what point we're looking at, because right now we're not worried about direction. We're not worried about position of those forces. We just want to know which directions they're acting in. So we have the 178.5, we have the 20.8, and here would be something like this, the resultant. So to get the resultant of two components, FR, we would take the square root of the sum of squares, and we would get 180 pounds. Next step, I want to get the theta, this angle here. That would be inverse tangent of the y component over the x component. And I would get theta is 6.65 degrees. And this was 180 pounds. So this is the resultant force and the angle at which it acts at. Now, the next step here, I'm actually going to copy this diagram down here so we can work through summing the moments about point O. The most difficult part about this is figuring out the moment arms. I'm going to say counterclockwise is positive. So I'm going to start with each component. So first, let's look at the 420 times 4 over 5 component. The easiest way to do this is to draw a line through the line of action of the force and then go straight down to where point O is. So actually, it's easier to see here. Straight down to where point O is. The length of this orange line is 4 feet. So the force is 420 times 4 over 5. The moment arm is 4 feet. The 420 acts clockwise, so it's going to be negative. I'm going to erase all that stuff so I can show you the next one. Next force is 420 times 3 over 5. So we have 420 times 3 over 5. I'm going to draw a line through the line of action of the force, 2.0. This distance from here to here is 7 feet, so my moment arm is 7 feet. This force here goes counterclockwise, so it's going to be positive. Next one. I have the 315 cosine 30. Here is a line through the line of action of that force. It acts 0 distance away, so plus 0. And the last one we have 315 sine 30. Here is my line through the line of action. The distance to O is 2 feet, so 315. And I'm going to subtract this because it's clockwise. Okay. I actually didn't get the sum of this, so let me plug that into my calculator real quick. Times 4 plus 420 times 3 over 5 times 7 minus 315 sine 30 times 2. And we get the sum of the moments, which is the resultant, is 105 pound-feet. Okay, if we want the sum around point P, very similar process here. So, that equals 0, whoops. Counterclockwise is positive. I'm going to do the exact same thing. Draw a line through, can't get the orange there, draw a line through the line of action for 424 over 5. It intersects with point P, so that one is 0. Next one. Let's look at this guy. Let's draw our line of action. How long does it take me to get from point P to the line of action? 7 plus another 5, so the moment arm is 12. So we have 420 times the 3 over 5 component, moment arm of 12. This is going in this direction counterclockwise, so it's going to be a positive. Next force is 315 sine 30. Let's draw our line of action through this force to point P. That is going to be 4 feet minus 2 feet, which is just going to be 2 feet. And this force goes clockwise, so minus 315 sine 30 times 2 feet. And then, let's clean all this up. Our last force is 315 cosine 30. This orange line is through the line of action. To point P, I have just the 5, so my moment arm is 5, and this force goes around in a clockwise manner, so minus 315 cos 30 times 5. And the sum of that is 420 times 3 over 5 times 12 minus 315 sine 30 times 2 minus 315 cosine 30 times 5. Oh, I plugged that in wrong. Let me see what happened here. There we go. Let me try this one more time. 420 times 3 divided by 5 times 12 minus 315 sine 30 times 2 minus 315 cosine 30 times 5. There we go. I got 1345 pound-feet. Okay, so make sure you guys can get all of these moment arms about any point on the system.